Good morning, this is Miss Webb. Okay, we're going to talk about scientific notation. I have a hard time with this one because you've been seeing scientific notation since you were like in 7th grade. But when we took the test on this, everyone really struggled. So I'm going to go back over it again and let's see how we do. Okay, definition of scientific notation. A number in scientific notation is written as the product of two factors in the form a times 10 to the n. But that a there, it has to be greater than or equal to 1 or less than 10. It's the integer. And this is where I had a lot of people, they'd get an answer and they go, okay, it's in scientific notation. I'm like, no, that a is wrong. Let's look at it. Do you see where the decimal right there, 2.3, isn't that between 1 and 10? 4.56 is between 1 and 10. 45.6 is not. 23 is not. 0.23 is not. 2.1, isn't that between 1 and 10? Well, I mean, remember, it has to be less than 10. So it's got to be between, could be a 9.9. That's it. The other problem we have is this n right here. When we talk about scientific notation, it's the one time I'm going to allow you to have negative exponents. The one and only time, can't do it on any of your others. Let's talk about this some more. Okay, so is this in scientific notation? No. 45. To be in scientific notation, it would have to be 4.55 times 10 to something. And I'll explain how you figure that one out. 0.45, no, it has to be 4.55. 3.3, that works for me. I'm good. Can I have that -2? Yes, I can. So this is just recognizing it. I'm going to show you how to put it in scientific notation on another slide. Okay, now, going from standard to scientific notation. There's different ways to teach this, and I'm not going to teach you a bunch of rules and going right or left with the decimal. I want you to think logically and think, okay, if a number is really big, that means you're going to have a positive exponent. If they're really small numbers, they're going to have a negative exponent. Let me show you this. Right now, the decimal is right there. So let's move the decimal where it needs to be. 1, 2, 3, 4, 5. So it should be 3.45. And how many places did I move the decimal? 5. And I know it's positive because it's a really big number. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, because I want the decimal place right there. And I know I moved it 12 spots and it's really big. It's going to be positive. Okay, for a small number, this is a small number. It's less than 1. I'm going to move it 1, 2, 3, 4, 5, 6, 7, because that's where I want the decimal to be. And look, it's a small number. It's going to be a -7. This one, I want the decimal to be right there. 1, 2, 3. So I think instead of trying to memorize, oh, I moved the decimal left, I move it right, I want you to think logically. When you see something like this in scientific notation, you see a negative, you're like, oh, that would be a really small number. Oh, this would be a small number. It's going to be smaller than that 9.8. 3.55 to the 10 to the 5th. It's going to be bigger. Okay? Okay, so, and here it is, writing a number in standard notation. A positive exponent means really big, and you're going to move the decimal to the right, because that's how you make the number bigger, right? 3.45, I move it 1 place, 34.5, and I move it 5 places. If I have something in scientific notation that's a negative, That means it's going to be really small. I'm at a 3, I make it smaller to be 0.3, so I'm moving the decimal to the left. But instead of memorizing right and left, just think big and small. Okay, now this is the one that really trips people out. And one of the questions, we won't have this specific question on your homework, but the question we will have is you're going to multiply and divide numbers in scientific notation, and the end result is not always going to be in scientific notation, and you have to put it in scientific notation. I'm going to show you the easiest way to do this. If I have 0.034 times 10 to the 6th, that is not in scientific notation. If I get an answer like that, it's going to be wrong. Where does the decimal place need to be? It needs to be right there in order for it to be in scientific notation. But that 10 to the 6th, is it going to be 10 to the 8th now, or is it going to be 10 to the 4th? Okay, well, I don't want to think about that. I don't want to have to worry about it. This is what I am going to do, though. And I like the way I do this. I want it to be 3.4, right? Now, can you make 3.4, what would you have to multiply the 3.4 by? Let me get a pen. To get to the 0.034. You're going to take this number and you're going to make it smaller. So wouldn't I multiply it times 10 to the negative 2? Is it 3.4 times 10 to the negative 2, 0.034? I gotta be able to go back and forth between my pens and the arrows. Aren't these two the same? Aren't those equal? Isn't that pretty easy to go, yeah, I got that, Miss Webb. Okay, now I'm gonna finish it with that 10 to the 6th there. And then here's what's cool. I'm going to use my law of exponents here. When you have the same base, which is 10, and you're multiplying, what do you do to your exponents? You add them. Negative 2 plus 6 is 10 to the 4th. That's how I know it's a 4, or is it 8? I can do it like this. Let's try it on this one. I have 340. So I'm just going to totally ignore this. And I'm going to write 3.4 in scientific notation. Miss Webb, you told us the decimal place has to go there. And since I'm going from a small number, I'm going to go to a bigger number because it needs to be equal to 340. And I moved my decimal place from here, 1, 2. There we go. Isn't this equal to 340? 3.4 times 10 to the 2. Okay, now I'm going to take my eraser and I'm going to go put in the 10 cubed. I got it 3.4 times 10 to the 5th. Now when we did this in class, I actually physically put an eraser that I have a magnet eraser that helped a little bit. Let's try this one. Okay, I'm going to ignore this. I'm going to look at 34. Can you write 34 in scientific notation? Because it's not in scientific notation right now. It would have to be 3.4. And it's just times 10. Or 10 to the 1, right? Because I need to make that 3.4. It's got to be a bigger number. It's got to be 34. So that's why it's a positive 1. Okay, now I'm going to go back and get that one right there. Let's go back and get this 10 to the negative 3. Use my law of exponents, and I got 10 to the negative 2. Because 1 plus negative 3 is negative 2. Okay, 3.4. I know that's equal to 3.4 times 10 squared. I'm good. Do you see how all of these work? Do you see how I have 3.4? That's kind of a small number, but when I multiply times a positive exponent, it's going to get to be a bigger number, which is 340. So instead of going right or left, I think of bigger, smaller. And I use my laws and properties of exponents to be able to figure out what to do in order to put this in scientific notation. Now on this one, now they want you to order the numbers. So let me put this one down here. This is 3.4 times 10. I just moved it over. Okay, so when you're going to put these in order, which one would be the biggest one? This one. The next, down to the smallest one. Okay? Okay, let's talk about multiplying, and this really confuses some people. Okay, when you're multiplying, you're going to have to remember your multiplication properties. It says 6 times 4 times 10 to the 4th. This is in scientific notation. The decimal point would be right there. And I'm not quite sure, but people really have a hard time with this one. But if I have 6 times 4 times 10 to the 4th, I want you to think of it like this. This is 3 times 4 times 5. Do you remember your rules? Can't that, or your properties? Isn't that the same thing as, well, that's the same thing. Can't you change that? Does it matter what order it's in when you're multiplying? It doesn't. It doesn't matter what order. You can change the order all around. Okay? So when I do this, I'm going to do 6 times 4 first. And I'm going to get 24 times 10 to the 4th. And it wants it in when you answer, you want to be in scientific notation. That is not in scientific notation. It should be 2.4. But to make that, that would be, okay, I'm going 2.4 small to big, I'd have to do that. Final answer. Okay, look at this one. 0.5 times 1.2 times 10 to the negative 3. Okay, now if you're having a hard time with this, you don't remember your rules for decimals, let's go get our calculator out and let's say 0.5 times 1.2, and I get 0.6. 0.6, which kind of makes sense because half, that's 50%, half of 1.2 would be 0.6. Times 10 to the negative 3. That is not in scientific notation. So I'm going to come get my eraser. Okay, I'm going to do the 0.6. I need it to be in scientific notation. Here, I'll put that back. Okay, I need that to be 6. I'm going to move the decimal this way. Times 10 to the negative 1. I have 6, which is a number, and I want it to be smaller, 0.6. So I'm going to multiply times negative 1. Then I put in that negative 3, 6 times 10 to the negative 4. Okay, let's look down here. Remember I said 3 times 4 times 5 is the same thing as 5 times 4 times 3. I could say this is 2 times 3 times 10 to the cube times 10 to the negative 5. What's 2 times 3? 6. Okay, now I have the same base. So what do I do with the powers? I'm going to add them. Okay, am I allowed to have a negative exponent? Yes, it's the only time SWEB's going to let me have negative exponents when I have things in scientific notation. Okay, let's talk about dividing. Dividing is going to be pretty much the same way. I'm going to look at these numbers here. This is the same thing. I'm trying to think of a good way to explain this. I'm going to do 6 divided by 3 and get 2. And you remember your division property? Same base, which is 10. I'm going to subtract them. That's all I'm going to do. Same exact thing. Let's see, I think that is my last example. So good luck with your assignment. Take your time because you use scientific notation in all of your science classes.